It's one of the first years they've had a food testing summit here at PitCon. So it was a chance to come and talk about molecular techniques. A lot of folks that are doing food testing are using traditional techniques, so it's a chance for us to introduce kind of the future of testing, where it's going, talk about big data and how it's going to change the way people think about even analyzing their food. Life Technologies brings a lot of capabilities into the Thermo Fisher family. We have traditionally focused on molecular-based testing. Oxoid Brands brings in some of the enrichment media that we use up front of our testing. We have great synergies with the SureTech line from Thermo Fisher as well. And so we've been very, very busy actually working with Thermo to start planning out our future together. Traditional testing has used relatively low bandwidth methods where you get a result is a pathogen present or absent in a food source. We have this interesting design tension in some of our technical offerings where folks will want a very simple plus or minus answer. At the same time, they want to be able to dig into the data very deeply. And so we're working on a lot of new user interfaces, actually spending quite a lot of time on the interface that the customer sees to afford them that ability to very simply get information, but at the same time dig in as deep as they want. There's pathogen outbreaks in food quite often. It's very common when there's an outbreak situation or an event of some sort. A very large food producer will contact us, want to get a consultation, perhaps do whole genome sequencing on a pathogen that's present or resident in their plant. We'll walk them through that whole process of sequencing, generating specific assays for them, helping them implement that technology, helping them with the data analysis and things like that. When you talk about whole genome sequencing and the value of that information, in an outbreak situation where you have no information about an organism, the entire genome of that organism has tremendous value. However, if you're looking to detect a specific pathogen in a food source like Salmonella, we only need 100 base pairs to do that. So that 100 base pairs has very high informational value, but the rest of the data in that particular testing scenario has essentially no value. So that idea of right-sizing the amount of information that we're giving them and where can they use that sort of information and making sure the information they get, the return on that is commensurate with the effort they put into getting it.